Let's do a quick review of research methods and then focus on sampling and sampling errors. Before we get started, let's practice identifying research. In this study, a disease is tracked for movement through different parts of the world. What type of research is this? This would be a description study. It's simply monitoring where and when a disease appears. Some students get confused between descriptions and correlations when there are years involved. But years are not variables. If we looked at height and test scores, those are two variables. They can each vary, and you could compare them through a correlation. But time cannot vary, so it doesn't count as a variable. Let's try another. A student researcher and I made two identical life cycle images, except one was circular and one was linear. We randomly gave these images to participants and asked if offspring will grow to be identical to or different from their parents. Almost 80% of participants said offspring would be identical to parents when given the circular life cycle image. Half as many said they'd be identical if they were supplied with a linear image. What type of research is this? This was a controlled experiment. There was one cause, the layout of the life cycles, one effect, the answer to the question, and all other variables were controlled. The participants were representative and randomly assigned, and the study is repeatable. Let's move on to focus more on sampling. Here are the learning objectives. Sampling is important for all research designs. We cannot study an entire population. If I'm doing research on people, I cannot have every person in the world in my study. If I'm researching insect damage on corn plants, I cannot examine every corn plant. I have to use a sample. But that sample has to represent the whole population. It has to be representative. If this is the entire population of cartoon people, and I can only sample one person, should I pick A, B, or C? I'd pick B because it's most representative. Now, you would never or rarely have a sample size of 1. If our population, though, was 1,000 times this group, I should include all members represented in roughly the proportion seen here. If I'm only interested in a population of cartoon people like A, I'll only select A people in my sample because they're representative of the population I'm focused on. So you start by defining the population you're interested in. Then you use an approach to select a representative sample. You could just pull names out of a hat, randomly selecting your sample. Or you could make sure that you have certain groups represented. You could make sure you skip nearby individuals to increase the range in time or space of your sample. Once you have your sample, you'll conduct your research. Then you infer that since the sample is representative of the population, your findings will represent or apply to the population. Let's quickly review from our last How Science Works lecture on reasoning. If we have a population, our sample is representative of that population, we find X information about our sample, therefore X should be true about our population. What type of reasoning is that? Deductive. If all the premises are true, the conclusion logically follows. There are two major sampling errors. The first is that the sample does not represent your population. Therefore, you cannot apply your findings back to the population. The second sampling error for experiments is that the assignment to different groups is not random. Let's say you're doing research on whether music helps students study. You have participants in a waiting room, and you just divide them. The right half goes into one room, the left half goes into the other. It seems random. But let's say there was a really loud concert the night before, and some students are wearing t-shirts from the concert. They gather together to talk about how awesome it was, but their hearing is damaged from the concert. If they all end up in one room, that could impact your findings. We'll look at sampling errors by using a real research study. This is a headline from a study that was so bad, I have no words. In this study, a group of researchers timed mammals as they peed. Their universal law, please excuse my sarcasm as I say that phrase, was that mammals pee for an average of 21 seconds, plus or minus 13 seconds. I'll let you digest that incredibly arrogant and ridiculous statement for a moment. Let's use this as another example for a review. The researchers went to a zoo or used YouTube videos to watch a variety of mammals as they peed, and they timed them. What type of research is this? This is a descriptional study. They're just measuring to find an average. Now, the important thing is that their conclusion included the statement that this average could be used for humans to determine whether or not they needed to visit a doctor about a urinary problem. What type of sampling error is occurring? Is it a non-representative sample, or is it a non-random assignment for experiments? This should be easy. Since this is not an experiment, this would be a problem with a non-representative sample. This study actually had two massive sampling errors related to non-representative samples. First, they didn't include humans in their study. If your sample does not include humans, you cannot apply your findings back to humans. Second, something like 70% of mammals are rodents or bats. 70%. This study did not include rodents or bats because they pee differently, in drops rather than streams. So you can't measure urination time. Saying that you found a universal law for mammals when you have discounted 70% of mammals is kind of a big error. The thing is, it would have been really easy to include humans. I personally didn't think that the 21-second average holds true for humans, so I had a class of students time their own pee events and anonymously submit the data. Here's what we found. Because a few people had some crazy long pee times, the average was 17 seconds, but the median was just 12 seconds. So most people pee for around 12 seconds. If we use statistics to predict a range of 95% of pee times, it should be 10 to 14 seconds for humans. While that does fall within the range of these researchers' findings, it's only because their range is unfathomably large, which of course is further evidence that there is no universal law of urination. But our sample wasn't that great either. These are college students. If we did a random sample of people, just the general public, would you think that pee time would be higher, lower, or the same? In other words, can you college students hold more pee, less pee, or the same amount of pee as the general public. If we added in people from other age groups or life situations, like older people, pregnant people, young children, their pee time would probably be lower. So the results of this study was that pee time is approximately 21 seconds. Our study was that pee time was 12 seconds, and that's probably at the high end. Do you think that this research should be used by humans to determine whether they potentially have a health condition or not? No, absolutely not, because they had a non-representative sample if they wanted this study to apply to humans.